Topic title: Course Overview.
Hi, I'm Aaron Sampson, and I've been a professional in the IT industry since 1990.
Your host for this session is Aaron Sampson. He is an IT trainer and a consultant.
The primary focus on technical training, I can be found most of the time producing and delivering learning content centered around network infrastructure and services. I've also been involved with extensive practical implementations in a variety of operational capacities, including architecture and design, deployment and implementation, administration and management, and various other technology-based roles. Computer hardware technicians must understand the basics of computer power systems, including amps, wattage, voltage, general guidelines for power sizing, and power supply options. The key lessons in this course include discussing the power system input, the 24-pin motherboard adapter which supplies power to all components of your motherboard, and identifying the amount of power required based on the number of devices in use. This course concludes with an examination of power supplies, which will help learners to determine the required voltage, as well as to differentiate between AC and DC, how to describe wattage ratings, and identify the maximum output of a power supply. This course will help to prepare learners for the CompTIA A Core 1 or 220-1101 certification exam. In this video, we'll talk about some of the basic characteristics of the power supply for your computer, beginning with the voltage that is specified by the power supply itself. Now, this specifically refers to the power that is coming in to the power supply, or another way to say that is the power that is coming out of something like the plug in your wall. Now, if you are in North America, almost all wall plugs deliver 115 volts, give or take a few, in terms of any given wall socket. So if you plug in just about anything into just about any wall plug, it will deliver around 115 volts to that unit. But if you're in most of Europe and many parts of Asia, then they will likely supply 220 volts in terms of the input. Now, this is important because many power supplies actually give you the ability to specify which type of input you are receiving. So if the wall outlet is transferring 220 volts, but then the power supply is set to only 110, then you're effectively going to deliver too much power to that unit, and it will very likely overload and quite possibly damage the device. Similarly, if the power supply is set to 220 volts, but it is only receiving 110, then it probably just won't even start to begin with. But what it comes down to is that you have to have the correct setting for whatever level of power you're receiving. Now, typically there is a switch on the back of the unit itself, and it's generally red in color and often located between the on-off button for the power supply itself and the cable. So if you look at the back of a desktop computer, for example, you'll generally see the power supply in the very top of the unit. It has its own on-off switch, which allows just the power supply itself to be turned off. But some power supplies don't have a manual switch. They can automatically detect the input that is coming in from the wall. Or it could be that this particular model will only work with the correct voltage. So in other words, if it's a 115 volt device but it receives 220, it simply won't turn on at all. So if you discover that yours is incorrectly set, simply turn off that power switch and reset the voltage switch to the correct value. Again, it simply has to be consistent with whatever you are receiving from your own power outlets. Now, that all said, if you buy a power supply in North America, it should by default be set to 115 volts. Similarly, if you buy one in Europe, it should by default be set to 220. And it typically requires something like a screwdriver to slide it from one position to the other. In other words, it's not exactly a switch that you could accidentally bump or knock to the wrong position. It takes a little bit of effort. But ultimately, you should always just verify that it is correct before you attempt to install a new power supply into your computer. Now, with respect to the power supply terms that you will undoubtedly encounter, there is the ampere, which is often abbreviated as amps, voltage, which is typically referred to as just volts, and watts. Now, amperes can be thought of as quite literally how much power there is. It's the basic unit of the electrical current and measures the rate of flow per second. So, in other words, if something has a very high amperage, it really just requires a lot of power. The voltage then can be thought of as pressure, or the amount of work that it takes to deliver that amount of power from point A to point B. Now, generally speaking, as amps go up, so will volts, but it's by no means a one-to-one relationship. For any given amount of amps, there can be a varying amount of volts that are essentially pushing on that power, if you will. But as I said, in general, as one goes up, so will the other. But since it's not a one-to-one relationship, watts refers to an overall value that is calculated by amps times volts. So this can be used to determine how much overall power is required and how much pressure or work is required to move that power. Now, there are also two types of currents. There is direct current, or DC, and alternating current, or AC. Now, in terms of the actual electronic components within your computer, they almost entirely run on DC, or direct current. But almost all of the power being delivered to our houses is alternating current, or AC. So effectively, every power supply acts as a converter to convert the incoming AC to outgoing DC. Now, the reason why both of these exist, in short, is because DC is, as its name indicates, direct. It's very linear and very consistent. And the components of our computers and mobile devices prefer this very consistent power. Alternating current means that it can literally alternate in terms of its flow or direction. So with that change in direction, it actually creates what's known as a sinusoidal wave, meaning that the power can be delivered from the power station in a wave-like format, whereas direct current is linear. And this allows for AC to travel much farther than DC. So both of them are required at the end of the day. We need AC to get from the power station to our houses, but our electronic components want DC, but they don't need very much. So again, every power supply unit can convert the incoming AC to the much lower voltages required, but in DC. So again, if you have something like 115 volts coming in to your wall outlets, this is simply far too much DC for any given electronic component. They run on much lower voltages. For example, something like your CPU or your processor only requires maybe 3 to 5 volts. So it's the power supply's job to regulate the amount of power that is being delivered to these internal components. But of course, that total amount of incoming AC has to be divided up among many different components, but any one component will only require a very small amount of voltage compared to everything that is coming in. So this actually comes back to why the voltage switch on the power supply needs to be in the correct setting. Because if you end up delivering too much power to any given component, it will almost certainly damage it. And if you don't give it enough, it probably won't start at all. So just be mindful of where you are and what kind of voltage variations there are in that area to make sure that you get a power supply unit that matches the incoming power supplied by the outlets themselves. In this presentation, we'll take a look at the varying voltages that can be delivered by a power supply, and they commonly include 3.3 volts, 5 volts, and 12 volts. Now, we'll take a look at each of these levels in greater detail in just a moment, but down at the lower levels, around 3.3 volts, this is typically the level of power required for the various chipsets on a motherboard, your dual inline memory modules, or your RAM, and most modern expansion cards. At 5 volts, this is where we find disk drives, specifically those with a spinning disk, single inline memory modules, which are quite out of date, but those are the predecessors to dual inline memory modules, and some older legacy expansion cards. And then up around 12 volts, we see really anything with a motor, most notably fans, and various types of voltage regulators. Now, the power supplies themselves have internal components known as rails, and each rail can be thought of as sort of a separate little power generator within the supply itself. So down at the lower levels, there is a 3.3 volt rail and a 5 volt rail, and again, these are for the components that typically don't require as much power, such as the various chipsets on the motherboard, the processor itself, anything that requires any kind of regulated power, and what's known as a buck converter. Now, just quickly, a regulator might also be referred to as a linear regulator, which is simply used for any type of component that needs very steady levels of power. Buck converters are, in fact, types of regulators, but they implement a more efficient mechanism. A linear regulator conditions the power by dissipating any excess power as heat, whereas a buck converter can actually implement capacitors to store that additional power so that, in fact, it can be used later on. So where a linear regulator simply just dissipates heat, which is really a waste product, the buck converter can use that stored power to help even out the flow in situations where the power perhaps drops too low. Now, there is also a 12 volt rail in most power supplies, and again, this is typically used for disk drive motors, higher output processor voltage regulators, and cooling fans. So quite simply, anything that requires more power. But quickly coming back to the regulator, again, this would just be something that still requires very steady levels of power, but at a much higher level than either the 5 volt or the 3 volt rail can provide. Now, with respect to the 12 volt output, it is worth mentioning that there are newer power supplies available that in fact only deliver 12 volts. In other words, there would only be a 12 volt rail. So for all of the components that operate at the much lower voltages, there would be additional regulators installed on the motherboard itself to reduce the voltage for those components. So rather than having 3 different rails in the power supply, you simply have this single 12 volt rail, which results in fewer components in the power supply itself, which translates into a smaller unit. Now again, since all of the regulation of that power occurs on the motherboard, you need to make sure that the motherboard you have supports a 12 volt only power supply. Now, on the topic of newer power supplies, it's also worth mentioning the entry-level power supply specification, or EPS. Now, this is typically only implemented for higher power-consuming computers, such as those considered to be entry-level servers. So this is where the entry-level term comes into play. It's not so much referring to the fact that it's new on the market. Rather, it would be for a system such as a network server that is considered to be more of an entry level, as opposed to something that you would find in a very large data center. Now, regardless of the status of the server, the EPS standard provides a more powerful and stable environment for more critical server-based systems and the applications they run. Now, the power supply itself is typically compatible with standard ATX or Advanced Technology Extended boards, or the ATX 12 volt motherboard, which in fact is that 12 volt only power supply that was just mentioned. But in most cases, you would also find 2 additional 4-pin connectors for the motherboards that do have higher power requirements. For example, if there are multiple CPUs on the board, or there are specific expansion devices installed that provide a particular service. So again, this is something that you likely won't find in the desktop or laptop world, but if you do start working with entry-level servers, you might certainly find that EPS power supply. But if it is a higher-end desktop, then it is likely the more compatible version, which still includes the standard motherboard connectors for ATX motherboards. In this presentation, we'll take a look at differentiating between the 20-pin and the 24-pin motherboard power connectors. Now, this connector itself is quite simply used to supply power and varying levels of voltage to the motherboard as a whole. Now, we might think of the motherboard as a single unit, but of course there are many different components that are either integrated into the motherboard or installed after the fact, such as video cards, sound cards, or any other expansion device. So the connector that we use to supply the power to the motherboard will ultimately supply power to most of those components, but in some cases there are additional power connectors that are required for some of those extra components. So beginning with the ATX connector, this was introduced quite some time ago, certainly going back into the 1990s, as the replacement for what were referred to as the P8 and P9 AT connectors. Now these were two separate connectors that each had to be attached to the motherboard, but again they were two separate connectors. The ATX connector connects directly out of the power supply to any ATX style motherboard using a 20-pin cable that typically consists of many multicolored wires, generally black, yellow, and red, and it was often also referred to as the P1 connector because quite simply it was the main power connector for virtually all of the components on the motherboard. Now from that point, the ATX 12 connector was introduced, which does not refer to the number of pins. Rather, it refers to the voltage. This is why it's also known as the ATX V12 connector, and it only in fact had 4 pins, so you might hear it referred to as a P4 connector in that regard, but this was typically for the CPU only. So we still had the 20-pin connector for the motherboard, but then newer processors required this additional connector specifically for the CPU. And again, it was implemented as a single 4-pin connector. But on the topic of additional connectors, on newer systems you may also find an 8-pin EPS 12-volt power connection. Now EPS stands for entry-level power specification, and despite the term entry-level, it doesn't really refer to the power supply itself. Rather, you might find these in more demanding systems such as entry-level network servers. As such, many of those have additional components such as multiple processors that require even more power. Now, as mentioned, you may see this in an 8-pin configuration, but in some cases you might also see it in a 4+4 connection, which in fact is built out of the original ATX P4 connector just mentioned, plus another one. But they can be separated from each other if necessary so that you can plug in just one of them, or in some cases they can be put back together for an 8-pin connector. Now, the other connector that you may encounter is the 24-pin connector, which is a very standard connector these days for many motherboards. It has a uniquely shaped set of pins that are keyed so that you can only plug in the entire connector in one direction. But it quite simply provides more power than its predecessor, the 20-pin connector, but it was essentially just the 20-pin connector with, in many cases, the detachable 4-pin connector that we just mentioned specifically for the processor. So, in other words, it was just the original 20-pin connector, but with the extra 4 pins integrated. But it was detachable in some cases so that you could maintain backward compatibility with the original 20-pin connector. Now again, this will come down to the make and model, but if you had a motherboard that only had a 20-pin connector and your power supply had 24, then in most cases you could literally just slide off the extra connector which contained the last 4 pins so that you could insert it into the 20-pin connector. And even if it wasn't a detachable connector, again, on some motherboards, you could still insert the full 24-pin connector into a 20-pin receptacle, and those extra 4 pins would literally just hang out over the edge, if you will, and just not be used. Now again, that would come down to the particular make and model, but most of the 24-pin connectors are backward compatible with 20-pin motherboards. Ultimately, they all still supply power to the motherboard and all of the components that attach to it. So it really just comes down to knowing what you have for a motherboard and what connector is present on that motherboard when you go to attach the main power connector. In this presentation, we'll look at some additional features of a power supply that should be considered if you're looking at an upgrade or possibly replacing an existing unit. So, of course, you want something that is going to perform well and provide reliable power, and really those are the two main considerations with respect to the performance. That generally refers to its efficiency, and we will talk about that in greater detail in just a moment. But the reliability is essentially the quality of the power. And in most cases here, it does often come down to you get what you pay for. In other words, you really don't want to look for a bargain power supply. All of your other components are entirely dependent on the power supply. So it certainly wouldn't hurt to do a little bit of market research. But again, typically a bargain level power supply really isn't what you should be looking for. Now, with respect to the characteristics, of course, one of the main considerations is quite simply the power output. And this comes down to what you have in your systems in terms of the components that need to draw power, most notably the CPU itself, your disk and or optical drives. So if you do still have traditional hard drives and or DVD or Blu-ray drives, then they of course have motors in them, so they draw a lot of power, as do fans. So anything with a motor really will have a fairly high power requirement. And if you have a high-end graphics processing unit on your video card, that is very likely going to have a high power requirement, as can other high-level expansion cards such as professional sound cards. Now, with respect to determining what the requirements for your system might be, there are online calculators that you can use whereby you simply input what you have for devices, and it will give you a general idea in terms of the overall wattage with respect to what you will require. Now, you should also be mindful of the continuous power level versus the peak power. Certain power supplies might indicate both. And with respect to normal operations on a day-to-day basis, the value you would want to be mindful of is the continuous power level. This essentially means that the power supply can reliably provide that level of power continuously, as its name indicates, but when necessary, it can peak up to a certain level. So you don't want to be running all the time at or close to the peak power level. You'll simply be pushing the unit too hard. So the continuous power level, again, is what you should be looking for. Now, another consideration is certainly the efficiency of the unit, and we'll talk about the ratings in just a moment, but clearly any unit that has higher efficiency will result in your system running cooler. It will probably be quieter overall and more reliable. It will have a longer lifespan, and in the long run, it will save you some money because, of course, when it comes to a power supply, if it's running at very low efficiency, it's quite simply pulling more power than it needs from the wall, and a lot of it ends up getting wasted. And wasted energy in terms of electricity is essentially just heat. So your system will just run hotter overall, which can simply result in a number of problems down the road. So with respect to the efficiency itself, you might look for what's known as an 80 plus certification. Now, it's referred to as 80 plus because that's the level of efficiency in terms of percentages, but it has to be maintained across various load rates, specifically 10%, 20%, 50%, and 100%. So 80 plus means that it can maintain 80% efficiency at all of those levels in terms of the load rate, right up to 100%. So if you just maintain 80, that gets you bronze. From there are small increments, but it goes to silver, to gold, to platinum, and titanium. And just to give you a general idea, the values might vary a little bit, but where bronze is just 80% efficiency across the board, titanium is up around 92 to 94. So silver, gold, and platinum are basically just somewhere in between, but the higher the level, the greater the efficiency. Now, something else to consider is the voltage rail configuration, specifically the 12-volt rail, because these are the components of the power supply that can provide the most power to the components that require the most power. So you'll often see amperage ratings for the 12-volt rails, and you would be looking for values around 18 amps, 24 amps, or 34 amps. Now, 18 amps would be adequate for most standard computers in an office environment, for example. But if you have even one enthusiast level device, such as a high-end graphics card, then you might want to see 24 amps. And if it's the very highest level system, such as a professional graphic design system, or perhaps an audio recording system, then you would probably want to see something like 34 amps. So again, it really comes down to the configuration of the system. But I should also mention here that many newer power supplies only have 12-volt rails, and they are referred to as 12-volt only power supplies. So if and or when the power needs to be stepped down, that's actually done on the motherboard. So in other words, there are no 3.3 and or 5-volt rails in the power supply itself, but those rails couldn't provide these kind of amps anyway. So again, you would only see these values on 12-volt rails. Now, the form factor might actually be one of the most important considerations, because this is quite literally just the size and the shape, which of course will determine if it actually fits in your case. So some common form factors include the Advanced Technology Extended, or ATX, the ATX 12-volt, and if you do see 12-volt specifically mentioned, then it means that it's a 12-volt only power supply. The EPS 12-volt, SFX 12-volt, and various others are also 12-volt only supplies, and these are a little bit newer and might be found in more specific systems. For example, the EPS stands for entry-level power specification, which is typically found in entry-level server systems, and SFX is small form factor extended, which might be found in smaller or, again, very specific configuration systems. Ultimately, if you aren't sure what yours is, then it might not be a bad idea to actually remove yours and take it with you if you are purchasing a new one, so that you can be sure that you get one that is the same size. Finally, you need to consider the power connectors that are available from the power supply, particularly with respect to your hard disk drives and or your optical drives. Now, these typically have the same power connectors, so it's not so much a matter of configuration, rather just how many are there. Then certainly the number of fans that you have in your system will be a consideration, and various other devices, again, such as video cards that often require their own dedicated connector. So again, it really just comes down to knowing what you have and or what you are intending to buy if you are doing a significant upgrade or building a new system, to ensure that the power supply has enough physical connectors for all of the components in your system. In this presentation, we'll take a look at some power sizing guidelines for a power supply with respect to ensuring that you purchase or acquire one that is adequate for your system. Now, we'll take a look at some specific examples of wattage and some of the devices that require the most power, but when it comes to any given power supply, more power is better than not enough. In other words, if you aren't really certain, then it's better to err on the side of caution, because if the power supply has more than you need, then it's not going to supply that extra power to the system for no reason. The components will simply draw what they need, and if there's some left over, for lack of a better word, it simply won't supply power for any given device that doesn't require it. So again, it's better to err on the side of caution, but you do want to be mindful of the total wattage of the power supply, and we'll take a look at some examples of that in just a moment. But of course, also the physical dimensions. You need to make sure that it is going to fit into your case, and with respect to the total wattage, you should be mindful of the total number of components that are going to require power. So again, we'll take a closer look at some examples of those. But in terms of the specifications, really this is what you're looking for to understand what level of power this particular unit can supply. So for starters, the AC input, of course, is what is coming in from your wall plug. and most notably the input voltage needs to be set correctly. If you are in North America, for example, then you'll want to check on the back of the device itself to see if there is a little red switch which allows you to adjust the input voltage, because if you are in Europe and many parts of Asia, it actually requires 240 volts. So if the device is set to only 110 and it receives 240, it could be damaged. Conversely, if it's on 240 and it only receives 110, then it might not start at all. So you'll want to make sure that is in the correct position. Then the DC output values refer to the rails in the power supply itself, and typically you'll see values such as 3.3 volts, 5 volts, and 12 volts. And there may be a negative 12 volt rail as well, but that's probably only there for backward compatibility. There were some older devices that did actually run on negative voltages, but they would be quite out of date these days. And the 5 VSB is 5 volts standby if you have a system that does offer standby power to certain devices. So again, those are what's referred to as the rails, but then you'll want to look at the maximum output current and maximum power across those rails to make sure that it can deliver enough power to the devices that require the most power. Now, on that note, the 12 volt rail would be the one that would supply the most power. In this example, you can see that it can put out a maximum current of 50 amps. And in fact, since total output in wattage is amps times volts, in this case, this gives you the exact total of 600 watts. Now, the 3.3 volt and the 5 volt can vary. So certain components running at 3.3 volts will not necessarily require 25 amps, and the same goes for the 5 volt rail. Those are just the maximum values, but in total, across both of those rails, in this example, the maximum power output is 140 watts. So then the total power output of 600 watts in this case really is the value that you're going to be looking for, and again, this really comes down to what you need for your system. So in terms of what do you need for power, again, just be mindful of the AC power coming in, the voltage level, 110 volts in North America versus 240 in Europe and Asia. Then, of course, the values for the direct current or the DC output that is going to the components of your system. And then you simply need to be mindful of what you actually have for components. So some examples of the more demanding components include video cards, and even a low to mid-range graphics card can draw 165 to 200 watts of power. And if it's a high-end graphics card, it can be as high as 350. So that alone is one of the most demanding components of almost any system. Then your mechanical drives, such as hard drives, can draw anywhere between 15 to 30 watts, again depending on factors such as the spin rate. And if it's a solid-state drive, then there's no spinning motor, so they require much less power, maybe around 8 watts. Other components include the processor itself, and for most Intel and or AMD consumer brands, you can expect somewhere around 75 to 125 watts. The motherboard and all of the other components might be anywhere between 30 and 80 watts. And finally, your memory will probably come in at around 3 watts per stick. Now, there are also online calculators available to assist you, and these can be particularly useful for systems such as gaming PCs, perhaps a media server, or a rack in a data center, because these systems typically have very demanding components and or very specific components that have equally specific power requirements. So again, these are just available online. You can search for them and simply enter in what you have with respect to all of the components, and it will come back and give you a much better idea as to what kind of wattage is going to be required to power all of those components. So this way you have a much better idea of what you should purchase or acquire to ensure that you do provide adequate wattage. And once again, it is always better to have too much as opposed to not enough, because if you don't have enough, you're always going to be driving that power supply at its maximum levels, and it's quite possible that it could overheat or possibly damage other components. So while a power supply with too much power might cost a little bit more, it could end up saving you money in the long run. In this video, we'll examine what's known as the redundant power supply, which is a component that you would typically find in network servers or perhaps blade servers that are found in large data centers. And the difference there simply is that a traditional server, for lack of a better word, looks like a regular computer, whereas a blade server is a rack-mounted device that typically has only the necessary components such as processors, memory, and networking. Most of the additional functionality would be provided by external components, so the storage would be entirely separate, as with the video connections and any other peripheral components. So those are typically found where you need a lot of servers in a very small amount of space. You might also find them with various types of networking equipment and control equipment such as monitors. But ultimately, the idea behind a redundant power supply is that it provides fault tolerance by implementing two or more power supply units. Now, quite literally, this means that there are two of them for any one device, and this allows you to implement a seamless transition in the event that one of them fails. Now, there can be some difference in the configuration here. In some cases, one power supply might always be running and it might be the only one providing power, with the other unit simply on standby. Or you might have both power supplies functioning at the same time with a certain amount of balance, if you will, between them. For example, if there are two of them, then maybe each one supplies about 50% of the power. Then if either one should fail, the other one simply picks up the load of the failed device. Now, you probably aren't likely to find redundant power supplies in personal computers, again, simply because these are typically implemented in situations whereby you have a critical system that has to remain running through various types of failures. Now, the other capability that can be implemented with redundant power supplies is what's known as hot swapping. This quite literally allows you to replace the power supply when it stops working without having to take the device offline. You simply remove the defective device and replace it with a new one. And again, since there is another power supply that is continuing to handle the load, all of this can be done while that system remains online. Now, another consideration is the power circuits that you have. If you have ever overloaded a circuit, just even in your own home, you know that certain things will go out. Now, in most cases, that's just a matter of having tripped the circuit. So if you can go to your electrical panel, you can just reset that circuit, but everything that was on the tripped circuit does go out. So in a situation where uptime is critical, ideally you should place one power supply on one circuit, then the other one on a different circuit, because if you still trip that entire circuit and both power supplies were on that circuit, then both power supplies will in fact go out. Now, another consideration when it comes to implementing fault tolerance or redundancy is, of course, just having that second or redundant power supply, but there is also the uninterrupted power supply option. Now, these aren't the same. A redundant power supply quite literally means that you have two power supplies within any given device, whereas an uninterrupted power supply is a separate battery-powered device that kicks in if the power does go out entirely. So just going back to what we talked about a moment ago with something like a tripped circuit, you can certainly just go and reset the circuit, but all of your power is still on in that case. You did not lose main power. So implementing a redundant power supply does not protect you from an entire power outage, whereas an uninterrupted power supply does. It runs on battery power. Now, the length of time you can run your systems on a UPS will vary significantly depending on the make and the model of the device and how much power you draw from it. So I do want to point out that in most cases, an uninterrupted power supply is usually meant to just give you a little bit of time to gracefully shut down all of your components, as opposed to them just immediately shutting off when all of the power goes out. That can damage your systems. So with the uninterrupted power supply, everything will stay running. Then that should give you enough time to just go and shut down all of your components in the appropriate manner to hopefully avoid any possible damage from the outage itself. Now, that said, you could have both. You could absolutely implement a redundant power supply in something like one of your servers, and then back it up with an uninterrupted power supply as well to ensure that you do have fault tolerance against the failure of a single power supply, and you have the time to shut the system down in the event of a complete power outage. For our final video of this course, we'll take a look at what's known as modular power supplies. And these are still power supplies like any other, specifically the traditional, but they do now offer what's referred to as either semi-modular or modular. And this quite simply refers to the physical wired connections in the power supply itself. So if we start with a traditional power supply, if you look at the unit, there are many different wires that are coming out of the unit itself that get connected to devices such as your hard drives, your video cards, your processors, and the motherboard itself. But on the power supply end, those wires are hardwired into the box itself. So in other words, they all just sort of hang out of the box and they can't be removed. Now, it doesn't necessarily mean that every single connector has to be used. For example, you might only have a single hard drive and a single optical drive, but there might be 4 connectors. So the result is that those 2 additional connectors aren't used, but they're just left hanging there in your system. Now, if we go right to the other end and talk about the modular, then there are no wires hanging out of the power supply at all. It's just the box. And it simply has connectors just like they do on the other end, but the cable can be connected and or removed from either end, either the device or the power supply itself. A semi-modular, as its name might indicate, would have both. There would be some hardwired connections. For example, every system is going to need a motherboard power connector, so that one might be hardwired. But since you can have a varying number of components, such as hard drives or optical drives, those might be modular, so you can simply install however many you need. So again, the semi-modular simply offers both options. Now, with respect to just the modular, or the entirely modular, if you will, this gives you the advantage of cable management because you quite literally only use the required cables. This helps to reduce cable clutter and also improves the airflow within the system because you don't have all of these cables that aren't being used hanging around blocking the airflow. So it will actually help to keep your system cooler overall and just leave more space inside the computer case. Now, of course, you do still need to be mindful of the physical dimensions. You may be able to find modular power supplies for some of the more traditional systems such as ATX or even ITX, but I would say they're probably a little more common in some of the newer specifications such as EPS 12 volt, which is the entry-level power specification, and the SFX 12 volt, which is the small form factor extended. And those particular models that do say 12 volt means that they only supply 12 volts. In other words, there are no 3.3 or 5 volt rails. When the power needs to be stepped down, it's done so on the motherboard itself. Now again, it's not that modular power supplies aren't available for some of the more traditional systems, it's just that they would be more common for these newer types. So ultimately, you just need to be mindful of what you actually have in terms of dimensions for your particular system. So double check the size. If you're considering a new purchase, for example, maybe measure out exactly what you have right now so that you can be sure that you have adequate clearance for the new power supply being installed. In other words, don't force it into place, because if it doesn't fit correctly, then you could end up damaging the device or possibly damaging the case. But again, the idea behind the modular power supply is the fact that it allows you to connect only those devices that are required. So you have fewer cables, you have a cleaner system, you have more space and more airflow, but it might cost a little bit more. So ultimately, of course, it is your call, but it can be a more efficient power supply as well, because again, you are only powering the devices that are present. Even though a cable that is not connected doesn't draw any power, it does still reduce the overall efficiency to a degree. So again, it's up to you, of course, but modular power supplies are certainly becoming more common. But as a final note, also just be sure that it does have enough connections to power all the devices that you have, because if you end up with not enough, then you simply will not be able to power those components. So in this course, we've examined various features of power supplies. We did this by exploring power supply input and output and wattage ratings, motherboard adapters and connectors, determining the number and type of devices to be powered, and redundant and modular power supplies. In our next course, we'll move on to explore how to work with multifunction devices, printer types, and printer consumables.